Hello, welcome to Block 2, Solving Problems with Multiplication and Division, Lesson 12. I'll share my screen. So, in your previous lesson, you learned about order of operations, otherwise called BIDMAS. And you learned that B stands for brackets, I for indices or taking roots of a number. And you're going to see that even in this lesson, we're going to make use of roots. And then D for division and multiplication, which have the same order, and then addition and subtraction, which have the same order. In today's lesson, you're going to learn how to solve problems using the area of rectangles and parallelograms. I would like to ask you for your favor, like the videos, share it with those you think could benefit, subscribe to the channel, and click on the notification bell so that when new videos are uploaded, you will be notified. By doing that, you help us grow our mission to educate the global population of children who may not have the financial resources to have high quality maths education. Thank you. Before we start, I would like you to do the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. For question 1A, 6 times 4 is 24, 8 times 9 is 72, 7 times 8 is 56, and 11 times 12 is 132. For question 2, you were asked what should be added to the diagram to show that it is a parallelogram. Well, we just need to add the arrows. So notice how we've used different arrows to show different sides that are parallel to each other. Okay. Next, you'll ask how many lines of symmetry does the rectangle have? So lines of symmetry look like this. So lines of symmetry are lines that you could draw on a shape such that the shape on the left-hand side or on one side, not just left-hand side, the shape on one side is a mirror image of the shape on the other side. Another way of thinking about it is if you fold the shape along the line of symmetry, it's going to overlap exactly. Okay? It's going to overlap exactly. Everything will match like for like when you fold it. Okay, let's do some new learning. Here, if we have the shape, what would we say the area is? What do you think? Well, you may have learned this in primary school. So each square is 1 centimeter squared. So because we have 6, the shape bounding or holding in it or around it, we have 6 squares, we say is 6 squared centimeter. Another way of thinking about it is, what if we're given the dimensions? Then we can actually find the area. And here is what you need to know, although you may already know this. The area will be the length times the width. So we could take away the grid and we can still find the area. Okay. What if we have something like this? So we do not know. You can see one side is 3 centimeter, but the other side is not an exact measurement using the grid. We cannot say exactly what this other part measures up to. But if we're given the actual length, then we can find the area. We don't need the grid. So we can just say the area is, again, length times width. Okay. So 3 times 2.2 will be 6.6 centimeters squared. All right. You've just learned how to find the area of a rectangle, whether it's in a grid or the grid is not given to you and then the dimensions are given to you. Then you know how to find the area of a rectangle. You multiply the length by the width. Pause the video and answer question 1. in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. So mark your work and celebrate your success. So notice here that this is 1, 2, so 2.5. So 2.5 times 1, 2, 3, 4 will give us 10. Okay. So sometimes it's possible to estimate if you see that it's actually on the middle halfway of the square. Let's do some new learning. If we have area and then we do not know one of the side, we can actually find that side that is missing. We just have to state the formula. The formula is area is length times width. We represent it exactly the way we should, but with this time to find the length, if you remember one of our lessons, you're going to have to do inverse operations. So if we have to multiply length times 7 to get 175, to get length, we have to do 75 divided by 7. Our answer will be 25 centimeter. What about this one? What do you notice? What do these marks show about this shape? What does it tell us? Well, you may have thought that these marks mean all the sides of the shape are equal. So it's a special rectangle, it's a square. Now, we're going to write the formula, but we'll write it differently because it means we do not have width, but we have length squared because area is length times length. That's what the square is. It's all length. There is no width. One side is not longer than the other. That's what we mean. Now, something you must know is if you remember, in our previous lesson, we said that the inverse of squaring, there was a lesson where we talked about bit maths, if you remember in our previous lesson, and we said in the indices, index and roots have the same order of operation. So I want you to think about this because you're going to use this knowledge in other aspects of maths. So when you're looking for something, if we were to write this, we would say 144. We would say 144 is equal to length times length, or length squared. So to get length, you do the inverse of squaring, which is square root. All right. So I want you to really pay attention to what we've just done here. Another way of thinking about square root is what two numbers would you multiply? These numbers must be the same to get 144, and that number is 12. Another thing, I want to extend your learning so that you really know this. If, for example, I write 27 is equal to length cube, so imagine we were doing volume. What do you think would be the inverse I would do to get length? Of course, I'm going to do cube root. So you do cube root. So the inverse of the inverse of index is the root of that index, the root using the root number to get the value that you would have used to do the index. So this is a bit like saying, what number will I multiply 3 times to get 27? And that is 3 times 3 times 3. Meaning the cube root of 27 is 3. That's what it means. So the square root of 144 is 12, because I can multiply 12 by itself to get 144 twice. Okay? Sorry, I can multiply 12 by itself twice to get the number 144. So I really want you to pay attention to this because it's a very important skill in maths. Let's move on. What if we have something like this? What do we do? Well, we can take slices of the shape and move it over and say, what exactly do we get? So I'll do it again. So counting all the squares, we would see that, well, our parallelogram is actually a rectangle that has 3 by 4 as its dimensions. So the area is 12 centimeters squared. But imagine if we put it back to where it was, you would notice something interesting. The height is still 3 centimeter and the base, that's what we call it for a parallelogram, is 4 centimeter. So to find the area of a parallelogram, I want you to pay a very important attention to this. We multiply the base by the perpendicular height. So the perpendicular height is the height that makes 90 degrees, yeah, you see, right angle with the base. So we're going to explore this a lot more, okay? So pay close attention. So base times perpendicular height is equal to area for a parallelogram, which is 12 centimeters square. Okay, let's look at this example. Here we seem to have lots of dimensions. Would it be possible to still find the area of the parallelogram in more than one way? Do you think so? Of course, yes. Because take note of what we said or what we've learned. The area of the parallelogram is base times the perpendicular height. Here we can see the base is 14 centimeter and the perpendicular height, so the height that makes 90 degrees with the base, is 5 centimeter. So the area will be 14 times 5. But we can still find the area another way. So have a think. We can still find the area in another way. Pause and have a think. Which numbers would we use? I'm sure you would have thought about the 10 and the 70. So imagine if we were to flip the parallelogram the other way around, you would see that 10 is the base and the height of 7 centimeter forms an angle of 90 degrees with the base. So it's a perpendicular height to that base. So the area is 7 times 10. So we get the same answer. All right. Let's now look at some questions that we could get where we have some algebra in the question, but it's not really difficult. So here we're asked, what is the area of the parallelogram when x is equal to 8 centimeter? Well, all we're going to do is, we're going to have to substitute 8 wherever we find x. So we'll substitute x with 8. But let's write the area the way we would normally do it. Okay, because that's what, we need to do when we find the area of a parallelogram, isn't it? So that side of the parallelogram is actually equal to this side of the parallelogram. They are opposite sides. Opposite sides of parallelogram are equal. Okay, remember, if you were to draw parallel lines, okay, you would, use the arrows. You know that by now, but you also need to know that the opposite sides are equal. Now, it means the base is actually x plus 6. And the perpendicular height, you can see that height makes 90 degrees with the base is x. So this is how we would want to calculate the area of the parallelogram. So all we need to do, we've been told what x is, we substitute the number 8. So remember your order of operation. We're going to have to do the bracket first. So 8 at 6 is 14. 14 times 8 will be 112 centimeters squared. It's now time for you to practice. So you've done a lot of learning. You've learned about how to calculate the area of a parallelogram. You've also extended your learning to calculate the length of a missing side when you know the area. You also extended your learning to find the area of a parallelogram when one of the sides is given to you as a variable plus a number. Remember, variable in maths means letter. Pause the video and answer questions 2 and 3 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here we can see that, we're told to show that the area of the parallelogram is 18. So if you count, you see the base is 1, 2, 3, 4, 5, 6. And we can see that the perpendicular height is 1, 2, 3. So 6 times 3 is 18 centimeters squared. Next, you're asked to work out the area of these parallelograms. We use the same approach. So you see the perpendicular height is 3, and here we have 10, okay? So 3 times 10 is 30. Same with this one. Perpendicular height is 3, and we have 10, okay, as the base. All right, pause the video and answer questions 4 and 5 in 3 minutes. Okay, assuming you've paused the video and you've answered questions 4 and 5, here are the answers. Let's discuss them. Here you're asked to calculate the area of the rectangles. By now you know how to calculate the area of the rectangle. You multiply the length by the width. Now, this is where your knowledge of integer multiplication comes in. So if you do not know how to do this, I'm going to ask you to go and watch that video again where we learned how to do integer multiplication. And then here is the same thing. You need to apply your knowledge of integer multiplication, either using the column method or the grid method, or you can use whatever method you know how to do for some of you who know how to do Vedic maths or other methods of multiplication. Question 5, we're told the rectangular garden has an area of 24 meters squared. Complete the table showing the possible lengths and width. Okay, so here, if the length is 8, and the area is 24, we just need to do 24 divided by 8. Here, 24 divided by 12, 24 divided by 4, 24 divided by 2.4, and that's will give us these answers. That's how we got them. Okay. All right, so mark your work and celebrate your success. Here is question 6. Pause the video and answer the questions in 3 minutes. Assuming you've paused the video, here are the answers. Let's discuss them. So assuming you've paused the video and you've answered the questions, here are the answers. Okay, so here is going to be 14 times 6. 6 is the perpendicular height. Here, although the parallelogram is flipped upside down, we can see that that is the perpendicular height. So it's going to be 9 times 18. Okay. Here, we can see that although the parallelogram is turned upside down, you can see that is the base, and you can see the perpendicular height. Okay, that line makes 90 degrees with the base, although it's turned upside down, so it's going to be 7.5 times 2. Here, you can see that the perpendicular height is this one here, 53, times 17, which is the base. That gives us our area. Pause the video and answer question 7 in 2 minutes. All right, assuming you've paused the video and you've answered the questions, here are the answers. So here we're asked, the square, rectangle, and parallelogram have the same area. Find the missing lengths. So we know that for the square, all the sides have to be equal. And we know that if one side is 10, the other side has to be 10. So this square has to have an area. Remember, the area for the square is length times length because they are the same. Yeah, they are the same length. Or or length squared. So 10 times 10 is 100, or 10 squared is 100. So it means all these, which have the same area as this one, have 100 centimeters squared as their area, 100 centimeters squared as their area. So it means to get the length of this one, we know area for this, which is 100, is 20 times width, which we don't know. So to get this, we're going to do 100 divided by 20, which is 5. This one, to get this, we're going to do 100 centimeters squared divided by 8, which will be 12.5. Question 8, pause the video and here we can discuss this. It says write 2 different calculations to work out the area of the parallelogram. So pause it and answer in 2 minutes. All right, assuming you've paused the video and you've answered the questions, here are the answers. So we can either do this one as the base, and you can see that is the perpendicular height to this base, 27 times 24. Or we can do 36 times 18. Yeah? And that brings us to the end of our lesson. So what have we learned so far? So in this lesson, you have learned how to apply your knowledge of finding the area of rectangles and parallelograms, and even finding the missing sides to, solve different problems. So one thing you need to know is that for a parallelogram, to find the area, you must use the perpendicular height. Not just any height, you must use the perpendicular height, even if the shape is flipped upside down. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself. Bye-bye.